everyone. This is Jill Hurston with Accelerate. Welcome to our webinar today. Go with the end game, build an MVP that can hyperscale. Today, we are joined by Rohit Sinha. He is Accelerate's Director of Product Development. Rohit has over 20 years of digital consulting product development experience and in program management. He's got a lot of experience with digital transformation, automation, AI, cloud, innovation, and much more. He works with many of our clients and many of our prospects. There's his information on the screen. He's spoken at several conferences and he's done a few webinars with us. So we look forward today to hearing him go into in depth on building an MVP that can hyperscale. So Rohit, I'm going to turn it over to you.
Okay, thanks Jill for the introduction. Right, so the topic, as Jill mentioned, go with the end game, build an MVP that can hyperscale. So that's going to be my topic for today. So we'll discuss of building MVP, what works best, what are the design considerations, and how we can run into challenges, and what is the best strategy going forward with an MVP that can hyperscale. So that's what I'm going to cover. So here's a quick introduction. Jill already introduced me. So yeah, so I live in Frisco, Texas with my wife and two wonderful daughters, work for Accelerate as a director of product development. You can follow me on Twitter. These are my email details. You can reach out to me on my office ID. You can also reach out to me on my Gmail. So let's get started. So let's first discuss the minimal viable product, MVP. So MVP is basically a product that has enough features which can attract an early adopter and validate the product idea. So that's when we go and build MVP. So that's what we basically want, is we want to validate the idea before we commit too much. So the purpose is that release to the market ASAP, as soon as possible. We want to release it and then test the idea with the real users before committing a large budget. So that's, again, that's the main objective of doing MVP. And then learn what resonates with the company's target market, right? What resonates with the customers. And then based on that, we can make changes, we learn, and then we can continue building more features on top of our MVP. So good examples, right? So most of the companies today come with MVP, and then once the idea is successful, when they see a market traction, they start building more on top of that. So an example can be like Airbnb, right? Air Bread and Breakfast company that started with a small application like MVP, minimum viable product, and when it starts getting more market traction, they just converted this into mostly like you are able to book your accommodation, right? If you are going for any activities or just make and have some fun in some place, just go and book your room there, right? Book a house. So that's a good kind of MVP. Similarly, Facebook is another example. So there are many examples which follows the MVP model and then they become huge. Agile methodology. So agile methodology is one thing which I really a big believer, and MVP is a core of the agile methodology. Right? Agile principles revolve around adapting to the changing market conditions. So it basically provides a framework where we can adapt to the changes, right? So we build with just enough features to satisfy the need of an early customers. And once we understand the customer, we understand what works well, what are their priorities, we can make changes to our original idea, and that's how that we build. So this is what Agile supports, and this is what MVP requires. So the advantages are speed to launch. So quickly we can launch a product to the market, right? Unlike the traditional waterfall. Flexibility, better product. So that's what like Agile methodology provides us, and that's where MVP is a good fit, where we can use Agile principles for the development
Hey,
during our
Rohit,
minimum.
I have a quick question. So are there any other software development methodologies that could also be a great fit with MVP development?
Right. So the other software methodologies like waterfall is one which basically we come up with the upfront requirements and more of a sequential model. So I see that may not go that well because the changes that the flexibility that we get for the agile, that really goes well with the MVP model. So
Okay,
that way, MVP is yeah, agile is a really great fit, and there could be some different forms of agile that can be applied on based on our needs, Scrum model, Kanban, and all those things. But I see that agile is a really
got.
good fit.
All right, thanks.
Sure. So one thing when we build MVP, there's a typical challenge which we can run into when our MVP gets popular, gets the market traction. Like when we start, like we get a requirement to build an application, right? We can start with a quick development. Product gets the market traction. So once product starts getting the market traction, we'll build more features. We develop new features, right, after the launch, and then users grow significantly. So that's where an issue can come, where now it is really difficult to scale the application. So that's a typical challenge. Like for example, if you go and build, say, a shopping application, right? You started with a quick development, you just come up with, okay, select these kind of items, and then from there on, you have a shopping cart, and then from there, like a feature like payment. So from there you start, but once that product gets popular, you started build more on top of it, right? You started building the delivery, different types of deliveries, and then different types of products. So that's where the challenge can come when your user growth is significant. Now how we are going to scale the the product that we built. So just to be more clear on this particular thing, I can give you a scenario where there is a team like team A example. Team A, they had to develop an MVP for a social media application, say an app like Instagram, right? So what they do that they said, okay, let's just go and build it. They decide what are the key features, and let's follow their methodology like Agile. Team quickly develops an MVP. They just launch the application, right? From a simple architecture point of view, this is just on the right hand side, I was showing a high level architecture, right? That's a mobile front end, and then they have application server, and then the request going to a database. So now what happens after that? The application gets good market traction. So it gets popular, and then that demand quickly grows to more than 10K user active on a daily basis. Application architecture needs to support the growing traffic. For that, what the team does is they vertically scale the application with a high-end server, right? That's an easy fix. So they provide more horsepower to their servers, like more CPU and RAM capacity. So that was able to handle the growing demand. User traffic further grows. Now they further horizontally scale the application with load balancers and database replication strategies. So that's how they start scaling it and fulfilling their ongoing user base demands. So at a high level, that's the architecture that they basically created. So mobile, like they added load balancer on top of it, and based on the demand and the different strategy, it decides which app server like it has to go to, and then from there on the database, it goes to the database. And on the database side, they come up with a replication strategy. So now after that, I mean, that's architecture was able to scale and be able to fulfill the demand, but the user traffic further grows, and now the users are more than 1 million users, which are globally distributed. So now they were running into a challenge where application was difficult to scale vertically because you can only add limited, like there's a limit to add the horsepower like CPU or the RAM, but you are going to reach a limit where you can't do anything more, right? So the database also exponentially grows and the architecture was not scalable. Now they need significant changes to the design strategy. So now the situation is either they had to stop the work or basically redesign the application, or they need to find a way so that they'll be able to fulfill the ongoing demand of the users.
Rohit, so you
Yeah,
say the team needs significant changes to the design strategy. Why is that?
right. So the significant changes to your design strategy is basically if you look at the architecture, right? So you have the application server, you have the database. Uh, that's what you try to do in order to scale, but there is a limit to it. The two things that you did, the development team has done here, like first they tried vertically scaling it, then adding CPU and RAM and more resources. Then they try adding more servers by horizontally scaling it. But again, there were challenges that they were not able to fulfill because the way architecture was developed, they follow a monolith design. So in that case, the application components were really tightly bound. So in order to scale each component, they had to scale everything. That was kind of a cost concern. Plus, the growing demand was not able to really just handle by the data replication that they suggested on the database side. They had to do furthermore, which I'm going to give you in the subsequent slide, like what are the other options that we'll have so that we can basically fulfill the demand of like more than 1 million users.
Gotcha.
So then there was another team, Team B. The approach that B did, they had a similar application where they had to build an MVP. The team they came up with the upfront questions regarding the scale of the product. So the upfront questions was like how many daily active users, right? What will be the user growth? What is the database storage requirement? How much we need to store? Right? What is the latency? And determine the key metrics for their application, right? So like what is the key metrics was here like the response time, the low latency, right? So some of the key metrics that they determine that give them a confidence that if we are able to satisfy and track these metrics, we'll be able to basically scale it and we proactively work in making this application successful. So after initial like intensive design discussions, team developed the MVP. They also followed agile principles. The user traffic grows as expected, but the architecture was able to scale. So this is what snapshot of an architecture, right? At a high level, that helps here. So if you look at, there are certain things like CDN, which is content delivery network, and database replication. So that's fine. Like you can also do with other component, but the key changes here was like a more of a service oriented architecture, right? It could be microservices or the services, because that way they these components help them really providing a granular way of scaling the application, right? The which component, for example, view data feed, right? On the page like Instagram, there was a requirement of timeline, like the data feeds, what other users are doing. So what they did was they had a different service which was handling it that was getting more user traffic. So they were able to scale this particular component, right? You can containerize the application, you can containerize this particular component, and you can have multiple instances, or you can further to like it is easily to really scale it without impacting other things. Then they applied caching on top of it. On the database side, still it was a relational database, but one thing that they did was for object storage like media, files, videos, images, this team used the object storage S3 type storage, which was very fully capable of handling this type of a traffic. That was helpful. But in spite of that, they also come up with a replication strategy. So that they had a read replica, which was handling the read traffic, the traffic that requires users to read the data. So that's another change that they did. So overall, this was more of a scalable design that can help, and they were able to reach to this conclusion because they had those upfront decisions, those upfront kind of thinking before they really start building the or jumping onto the development. So what went wrong with Team A? in this case was lack of upfront design thinking, right? Some of the key considerations like data storage, object storage, like S3 versus RDBMS for images and videos, monitor the availability, which is very important because that's you can proactively determine how the traffic is, right, where the issues are, and then you can strategize your further development work. Service-based architecture, caching strategies. So see some of these design considerations they were missing in this particular case. So let's just talk about key design trade-offs that helps building your applications and MVPs. So availability versus reliability. Availability is one of the key things that we should always look at and monitoring. Like we should be knowing how much application is available when there's a growing traffic. So it is also known as an operational availability, is expressed as percentage of time that system is operating compared to a total scheduled operational time, right? The three things that we need to know, like the ability of the system to perform a task, is the system is responding, did the response arrives in time. So these are the three things which are very important for the application. So consider we build an application, right? And then we build an MVP, right? So MVP works well initially when the traffic grows. Now, once the traffic goes, what we found there's an outage. Okay, that's one of thing that was taken care of. 2 weeks later, there 2 times the system was down, and then again we fixed it. But 3 weeks later, there was again an outage, and then so that makes the thing really challenging. So we need to be making sure that system is scalable, and availability is one of the key area. Reliability is the probability of success and the dependability of an asset to continuously be operational without failures for a period of time. So we need to also make sure that the system is reliable, right? If it is system is returning say 2 plus 3 is equal to 5, so every time whatever wherever or within how much traffic you have, the system should be returning 5, shouldn't be 6 or 7, right? So that can be taken care by testing strategies, making sure we cover all the test cases and all those things. But the availability is important, and in order to improve it, we need to make sure that we are monitoring it, we are measuring and tracking the availability. So one of the formula for measuring the site availability is like site availability percent for a period is equal to total seconds. Like if you just monitoring in seconds minus seconds period system down period divided by total second period, right? So basically the total number of seconds that system is expected to support minus the downtime in seconds divided by the total number of seconds. So that's how that we determine if it is a 99% availability, 98.5 or whatever, right? So we need to monitor it and see where like automate the manual processes, right? If there are multiple servers and you see there is a issue on one server and you apply a fix, it works well, and make sure you apply the same fix to all the other servers because that will make all the systems consistent. Similarly, automate it, make sure it goes through a version control. We need to make sure that we also have a process where maybe whatever fix that we are applying, just reviewed it by a third party or reviewed by another team, and then go through a version control, have that history there, and then deployment should be automatic. So that's another thing that we need to make sure. Circuit breaker pattern, like handling how we are handling the dependencies. This is also important. Now consider the same like shopping application, right? There's a product, and for that there is a third party service which you are using. So we need to, when we are developing it, build with a mindset where you're just trying to analyze all the risks. So if that service goes down, we don't want to go down the, like we don't want to have the whole complete system get down. So handle those things, right? In that case, wherever the third parties are, handle this gracefully, right? Considering that it can go down, give a proper message. The other thing is like mitigate risk, right? The same case, a risk mitigation strategy would be that if the third party there's a traffic on this particular product, right, and it is difficult to respond to the growing demand, what we can do is instead of showing an error message, we can just redirect it to another page where there could be like we can show a compatible product, and then we can also apologize and maybe give a 10% discount, right? So that probably go well than just showing a error message or a simple message that the service was down. Now again, we need to decide like what we are going to go with, like what is our development framework. Will it be a monolith service-based architecture? Because monolith architecture also has its own importance. Like if you are making a building a kind of an in-house application, right, that can support say 100 users, I mean, know that it's not going to be beyond 100 users, or maybe it can be 200, but it is just an in-house application. So the advantages here are that easy development, simple framework, data integrity, right? The disadvantages are like agility issues, poor modular design, difficult to scale. But again, we need to make sure that whatever design strategy we follow should align to the demands that this application is expected to support. Like microservices, if you just go with a microservice, so microservices, it is a scalable architecture, faster development cycle, isolated services, fault tolerance, right? But it requires more collaboration, performance issues, security issues, complex testing. So all these things needs to be taken care of. But if your application needs to support the scalable design, right, the incoming traffic is going to be like say 1 million users, so better to go with a microservices design. The thing is like cloud native, right? Cloud native is also kind of a microservices, but the good thing is that it is scale as needed, quick development, quick deployment cycle, pay per use. That's another thing, kind of cost effective in a way. If we really understand the architecture, we know how we need to use it. So that would be a good architecture. Performance wise also, it is able to scale based on the demand. The only disadvantage is vendor lock-in. So if you just go with a AWS, in that case, there will be difficult if you need to migrate it to from AWS to GCP, right, or to the Azure. Now, monolith versus service-based architecture. So as I mentioned, right, contains a logic. Monolith contains a logic within a single component. So multiple teams working on an overlapping areas impacts the code quality and availability. So if we go with a monolith design, we need to make sure that what it comes with, that application generally is going to be highly coupled. Then even though if you assign different teams to different components, there will be dependencies on in a highly coupled environment on these applications, on these components, so which is difficult to scale. Then you will lose the scalability based on component, like the component wise scalability. Again, that may not be a cost effective thing. The other thing is the service based architecture, the scaling benefits, right? The separation of work is needed for the highly scalable application. That is a given thing. So if you are building an application like again the shopping application, you need to decide the different services. There could be a add cart, right? And there could be a service like payment, delivery, item selection, right? Delete. So you have to divide these services, split application into different domains, managed by different teams. Different services have different scaling needs. Again, there is, for example, on a Amazon, right? Amazon, if we go with the Amazon and order like if we order items there, so in that case, like it might need to support 10 million transaction per second, right? So the application is scalable, but there would be an order history page. It has a different kind of a demand, right? So you need to see like what demand each component has. In that case, you need to design your architecture. So in the same example, there is an order history page that needs to be built. We need to see, we need to what design strategy, architecture strategy that we'll go with. So we probably go with a different architecture, right? We probably design a service that can basically extract the data from the transactional database and put it in a database like MongoDB or something like that, and that way we can decide. So different services have different scaling needs. Implement scaling for each component to make system highly scalable and cost effective.
Hey, Rohit, could you elaborate the scaling for each component to make the system highly scalable?
Right, that's a good question, Jill. Right, so that way, as I mentioned, right, each component has different scaling. So there could be some components that requires very less user traffic. There may be a contact us page, there may be something like support, right? It may not have huge traffic. So that way, if you allocate resources to these services in a similar manner that you allocate resources to use cases like order or order history. So that may not be a good design because you are giving more resources towards it. So you need to decide based on the component what scalability that this component needs, what latency, what is the acceptable latency, right? What should be the response time? On that basis, you determine how you can do it. You can use it with the Docker, right? The containerized application, have multiple instances of it, or you go with the microservice and then just scale it there. So that's where you can decide. Any other question?
No, that's it. Thank you.
Okay. So the scaling benefits are like save system resources, as I mentioned, component-wise scaling, then provide ownership of scaling decision to the team and that owns the service. So that's very important. So team will have the ownership. Now in the diagram, if you see on the right-hand side, each team has components assigned to them, right? A team can have one component, multiple components, but no component will be shared by multiple teams. So that's a best practice. So service should meet the following criteria, right? Should have specific business requirements, then maintains separate code base. It should have its own data store, and there should be a single owner. So these are the main important considerations that we should have when we go with the microservice or service-based architecture. Now, the ownership, no service, as I mentioned, it should be assigned to more than one team. Individual teams can own more than one service, and team should be responsible for all the aspects of service. So that starts from architecture, design, development, testing. So everything should be taken care by that team who is responsible for the service. Now, scaling with microservices, right? So microservices, this is another example of service-based architecture. The main thing is how much computing resources each service will need. So that way we can carve out the infrastructure partition and divide them between the microservices. The small team will just follow the same. Fault isolation is one of the benefit. So that way you really know like where the issue is. Pair well with the containers, like it helps dynamically scalable at runtime. So that's a dynamic scalability that we can get if we just containerize our microservice into containers. So scaling with Kubernetes, right? So containerize your application, use Kubernetes to automate the management, scaling, and deployment of microservice applications. So this is one of the main advantages where you can really automate the overall management, and based on the on-demand scaling need, it helps in really scaling your Kubernetes cluster. So a Kubernetes cluster is a set of nodes that run containerized application, right? So in a multi-cluster architecture strategy, which is like spinning up several clusters to achieve better isolation, availability, and scalability. So this is really very helpful when you want to design a application that can support the high demand. So Kubernetes auto scaling feature automatically scales your application, scales your cluster as soon as we need it. So that's the advantage. So the basic advantage that we get it from multi-cluster deployment is like low latency, easy to deploy workloads close to the group of the user based on the geography to reduce latency and improve performance. So that's one of the important thing, that we can deploy our workloads based on the different user groups, right, on geography. So that can help reducing the latency. Availability, now we can spread clusters between different data centers, right, to avoid the risk that arise from the failure of a single data center that can disrupt the whole development. So that way you can just deploy it on multiple data centers and then avoid this risk. The other advantage is scalability, right? Running more than one cluster will improve the overall the availability to scale up workloads whenever required. So you can, based on the demand, we can determine like how we want to scale our clusters. Security and compliance. So in case of geographic regulatory requirements, a cluster, multi-cluster strategy is a great help here. A cluster can be deployed on a location that addresses those needs, right? So that way you can determine which application components or which that you don't want to deploy on certain geographies, so that it can conform to the regulatory compliances. Now, another design consideration is the database replication. So it is a proactive strategy to help application scale, right? So that way you can determine if if you want to improve the availability of your database server. So database can be replicated across multiple nodes. So that can decrease the latency and it helps in improving the overall performance. So that way, if you are, it's kind of a leader follower replication strategy. So in that case, if one server fails, if the master says the primary server fails, the secondary server can own that, and then you'll have the application still be available. The other design consideration is between SQL, NoSQL, right? So which is a database sharding. With data increase, there is a bottleneck in the traditional database. So in that case, we can go with a NoSQL model, right? Even with high-end machine configuration requirements, with the traditional database, it exceeds the capacity. So in that case, the sharding is a good database partitioning strategy which separates large database into smaller, faster, and kind of more easily managed parts. So that the example that on the right hand side, right, you can just shard it on the basis on a your serial number or whatever, right, and then you can divide that data into multiple shards. So it really helps a system to scale out as the size of the data increases, and it also helps unplanned outages don't take out the whole system. So that's another advantage that we get on the database sharding. So these are the design considerations that we should always look into when we are developing our architecture. Load balancer is another important, like horizontal scaling, efficient distributed incoming traffic to maximize the system capacity utilization and minimize the queuing time, right? So you can have a load balancer when we see there is a load, growing load on the application. You can add load balancer, which can distribute the load within your servers, and you can have multiple strategies like round robin is one of the strategy. Least connections, the server that has least number of connections will get the next, like load balancer will redirect the traffic there. Similarly, consistent hashing, right, based on the IP or the URL, it determines where it can send the traffic. So microservice architecture, so it can be used in front of these services where we need to scale it, right? If you have a microservice architecture, you can determine with the load balancer, right, where we want to, where you see the bottleneck, you can have multiple instances of those servers, and then you can scale your application. Now, the other consideration is caching strategies. So the benefit of caching is that it is implemented with, I would say that it is as a more expensive and less resilient hardware, right? So the benefit here is that if you have a cache in between your application server and a database server, for example, right, you can reduce the traffic goes to the database and then coming back. So instead, you can just take it from your cache, right? So you'll have like different types of cache: in-memory cache, where each server maintains its own cache; distributed in-memory cache, where separate caching servers such as memcache or redis can be used; like database cache, file system cache like CDN, and then you'll apply different policies: first in, first out, least recently used, least frequently used, right? So that way you can apply how you want to basically serve the users, right? So it could be like pull or the push methodology, like CDN. Will go in the next slide and we can talk about that as well. So CDNs are like content delivery networks. That's another design consideration. It is composed of a group of servers that are spread out globally. So no matter how far the server is from the origin, they will always be closer to the CDN server. So that's one of the very important strategy. Like consider a case where you have a center in an offshore location and they need to really access the medical images, uh, and then the hospital is in US. So in that case, one way is you can just use the client version of it and then try to access it, but that could be very slow, and in some scenarios you really need the speed. So the other is if you just use a CDN server, right, go with the cloud version of it. So that way you will have your contents available near to your location. Again, there are different ways of applying, I would say there are different ways you can implement CDN, like push CDN and the pull CDN. Like the push CDN, origin server sends the asset to the CDN, which stores it in the cache, and the CDN server never makes any request to the original server, right? So that's where the push CDN is, where you're just pushing that any changes and then pushing it proactively to your CDN, right? So that way they are not going to make any trip to the origin server. The pull CDN is a different strategy where CDN doesn't have the static asset in its cache. So when they don't have it, then it forwards the request to the original server and then caches the new asset. So that's another way. Now it depends on you and your architecture team, like they go and decide like what makes sense. But these are the considerations if we do that really help making sure that our system is a scalable system, be able to fulfill the growing demand. Now, upfront questions and key success metrics. So when we get a requirement to build an MVP, as I mentioned, the team B, they come up with the upfront design questions, right? The questions could be, okay, how many users this application is supporting? Like TPS, right? Transaction per second. How many transactions per second is acceptable? What is an acceptable response time? What is an acceptable latency? How much data it needs to support? What is the next 1 to 2 years roadmap? So these are the design questions, right? And based on individual MVP or based on different requirements, you can have a different upfront design. But these questions should be good enough that can really understand like what should be your architecture strategy. So now if we know beforehand that if the application is successfully, very soon we'll get the big user traffic, right? We'll expect like 1 million user or maybe more in couple of months, then we understand that what type of traffic that we need to support. So based on that, we can decide.
Hey,
Determine,
Rohit,
yeah,
Rohit, could you go back one slide? Um, as you were going through that, could you just elaborate a little bit on how much of the data needs to be stored?
right. So that is again a good question, Jill, right? The data needs to be stored. So that way we need to calculate like how much data is required. If it is how, what is the data, what is the growth in the data? Right now if the daily active users are say 10,000 users, right, and if it is a Instagram like application, so one you can expect like each user is say in a week's time uploading 2 images or videos, right? You need to see okay how much would be a general size of it. If it is 2 MB, then you could just multiply it by total number of users in a week's time, 10,000 by 2 MB, so this much of a data that is expected in a week's time, and then a month's time, and that way you determine okay over a period of time what is your database, what is your data requirement, and then you can make a decision like what database will be appropriate for you. So if it is if it is an RDBMS database, or we just go with a NoSQL database like DynamoDB, MongoDB, right? Or do we need a object storage like S3?
Got it. Okay, thank you.
Okay. So based on that, we can determine what would be the key success metrics for this application, right? We'll determine these. It could be average response time, latency, daily active users, monthly active users, net promoter score. I think that's very important, right? The customer satisfaction, user satisfaction is also an important factor in determining it, the overall success of the application. So these are things that we that can be a good kind of a success matrix for your application. So the architecture options, right? So based on the number of users, like what I see here, if the user traffic is say less than 1,000 users, daily active users, right? The architecture choice could be monolith design, the application server, as you see in the on the right hand side, right, business layer, and then we have a database, RDBMS, right? The value that we are going to get is we'll have a quick development, and then there won't be that much of a complexity required, and it's a very simple architecture. So that's one consideration. If you know beforehand that how much your daily active users would be. The other case is the number of active users, say 10 to 100,000, right? These all are globally distributed. So in that case, the design considerations would be microservices. I would rather go with a microservice than a monolith design. We can have multiple servers, and then you'll use load balancers to distribute the load. We can go with a database replication strategy. We can still go with RDBMS, right? And then through a database replication, we'll be able to increase the availability of our servers. We can add content delivery networks, so that way we can reduce the round trips to the original server. We'll have the CDN there, and then we can basically scale the application. So that's another criteria. Now The third option is now we say, okay, this is going to be like 1 billion user, globally distributed. So in that case, I would say the architecture should be designed like microservice, a very good architecture, right? We'll continue to have like multiple servers there. We need to have more application servers, database servers, right? We need load balancers in front of them. Then we can follow different strategy if you are using like RDBMS, right? Leaderless replication, where so that you can follow. Then the database sharding, which is just go with the NoSQL kind of database where you'll be able to shard it with the automatic user request going to an appropriate location based on different strategies that you decide. For the storage of media, if you see there's a big traffic, right? If there's a big kind of a storage requirement there, then we can go with the object storage, right? S3 can be an example, right? We can use the object storage because they are really robust enough and they have the architecture that can support these bigger files. So all we can do is we can just have in the in our database have the location and then the location of these kind of a server location of the file, and then from there we can access those media files. We can containerize the application. This is very helpful. And then CDNs, right? The content delivery network. So that's how that we can support like when the user traffic is really very high. So I think that's all that I wanted to cover in this session. And Jill, do you have any other question?
I don't. We have no other questions that have come in, but this was great. This was really helpful. And I will make sure that this gets on our website and on demand. So everybody will get a link to that. And if you have any questions for Rohit here, definitely take note of his information, and I'll also send that out in an email to send out to everybody. But Rohit, I do want to thank you for a great webinar. This was great, very informative.
Right. Thanks, Jill, and thanks everyone for listening. Thank you.
Yep, thanks. Bye-bye.
Yeah, bye-bye.